Hello friends, welcome to Siddha.com. Now in this video we will learn about the atomic mass of an element. We know the atomic mass is a very fundamental property of an element, and the atomic mass is generally expressed in terms of the atomic mass units AMU. In our everyday life we use the kg as a base value, as a reference, so we express the weights of the substances in the kgs. However, we can't use the kg for expressing the mass of the elements, because kg is a way too big unit for the atomic mass of the elements. So hence we use a very smaller unit, which is atomic mass unit. One atomic mass unit is defined as the mass exactly equal to 1/12 the mass of the carbon 12 isotope. That means one atomic mass unit, 1 AMU, is equal to 1/12 the mass of the carbon 12 isotope. So carbon 12 isotope is taken as a reference here, right? It's taken as a reference. And we express the weights of other substances with respect to this reference point. So 1/12 the mass of the carbon 12 isotope is a 1 unit, 1 AMU. Let's explain it with this diagram. Suppose this is the carbon atom, this is the carbon 12 isotope, and if I cut this carbon 12 isotope into 12 equal parts, say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. The mass of the one piece of this carbon atom will be equal to 1 AMU. And 1 AMU, when expressed in terms of kgs, is equal to 1.6607 times 10 power 27 kgs. You can see how small this unit is. Okay, 10 power minus 27 kgs. Okay, very small unit. So in terms of atomic mass units, elements like hydrogen, sodium, oxygen and other elements, the atomic mass comes up. For hydrogen it is 1 AMU, for sodium it is 23, oxygen it is 16. Similarly, you can check it for the other elements in the periodic table, which means that the weight of the oxygen atom is actually, it is 16 times the 1/12 the mass of the carbon 12 isotope, right? Okay, it means oxygen, it has a weight which is 16 times 1/12, right? It is 1/12 the mass of the carbon 12 isotope. So similarly for sodium it will be 23 times heavier than 1/12 the carbon, 1/12 the mass of the carbon 12 isotope. If you check it from the periodic table, for most of the elements you will see that this atomic mass comes out fractional value. If you look at the chlorine in the periodic table, the atomic mass is 35.5, right? This is the atomic mass of the chlorine there in the periodic table. Similarly for the copper, you can also find it, it will be, for the copper you can see there it is 63.5. Why this fractional value? The reason for this is that for these elements where you find the fractional atomic mass, right, basically we are taking their average atomic masses, right? Average atomic mass. Most of the elements occur in nature as isotopes. Isotopes, we know, are the elements having the same atomic number but different atomic mass. Chlorine, we know its isotopes are, one of the chlorine is chlorine 35, atomic number is 17. Another isotope of the chlorine is 37. their natural abundance, we find them in nature. Chlorine 35 is 75% of the total chlorine, and around 25% of the total chlorine is chlorine 37. So this is the natural abundance, right? That means it is almost in the ratio of 3:1, right? This is almost in the ratio of 3:1. Elements like these, which exist in the form of isotopes, we express their atomic masses in average atomic mass. For the chlorine in the periodic table, you will find the atomic mass will be 35.5 AMU. The reason, because the chlorine exists in different isotopes, and the atomic mass that we take here in the periodic table is average atomic mass. So this is an average atomic mass here. How do we calculate the average atomic mass from the percentage? Average atomic mass, average atomic mass of an element is actually equal to the atomic mass of the one isotope here is 35, and it is in the ratio of 3:1, right? 35 and 37. So I'll write down 35 times 3 plus 37 times 1 here, divided by 3 plus 1. So it is it will come out 105 plus 37 divided by 4. That will be equal to 142 by 4, which is equal to 35.5 atomic mass units, right? AMU. So that means 35.5 is the average atomic mass of the chlorine. Average atomic mass of the chlorine.